Okay, this is student notes 10.7, surface area and volume of composite figures. Composite figures, remember, are just two shapes that have been put together. And so in this case, our composite figures are made up of two different three-dimensional figures that have been put together. So in example number 1, find the surface area of the figure below. So we're going to be doing surface area and volume today. This one we happen to be finding the surface area, and the two shapes that have been stacked on top of each other are both pyramids. And if we look at the base of the pyramid right here, we can tell that this is a square, and we know it's a square because it has these little markings on each one of the edges that indicates that each one of the side lengths of our square is the same. Mine's gotten cut off a little bit right here, but this is an 8. So each one of our side lengths of our square is 8. So in order to find the surface area of a pyramid, we have to go back to our formula chart. And as you notice, the surface area is just the faces that are exposed. The actual base here is not exposed. It's not on the outside. So it's actually not on the surface because the two bases of both of the pyramids are on top of each other, and so the square is not facing the outside. So really here we're just finding the lateral surface area of both of the pyramids. And if we look at lateral surface area on our formula chart, the formula is 1/2 P times L. This is coming straight from your formula chart. You don't have to memorize it. And remember that P means the perimeter of the base. And remember, our base is a square, and if each of the side lengths are 8, you count up all the sides, 8 plus 8 plus 8 plus 8, or 8 times 4 is 32. Okay? And the lateral surface area of this first figure would just follow our formula, 1/2 times our perimeter, which is 32, times our L, which remember stands for slant height. We're looking, we'll go ahead and do this first, the top pyramid first. The slant height of this top pyramid is 15. So when we do 1/2 times 32 times 15 in our calculators, we get 192. So 192 feet squared is the lateral area of our top pyramid. Now let's look at our bottom pyramid. The perimeter for our bottom pyramid, the perimeter of the base of the bottom pyramid is still the same because both of the bases are stacked on top of each other right here. This is the base of both of the pyramids. So the perimeter for the second pyramid is the same. It's 32. Okay, so we're going to follow our formula to find the lateral area. The lateral area is 1/2 times perimeter, which is 32, times our slant height of our second pyramid, or our bottom pyramid, which is right here. Horrible, but you can see that it's pointing to the 18. So in our calculators, when we do 1/2 times 32 times 18, we get 288. So the bottom pyramid is clearly larger than the top pyramid. And then it asks you to find the lateral area of both figures. So really we're just adding 192 plus 288 together to find the total lateral area. 192 plus 288 is 480. So the total lateral area of both of the figures is 480 feet squared. Remember, it's still squared because we're talking about surface area. Okay, but if it talks about volume, that's when we would use cubes. Okay, example 2, we're going to go ahead and save for class. So let's go ahead and move on to example number 3. Okay, example number 3 is asking us to find the volume of the composite figure. Okay, so not doing surface area anymore. We're looking at volume. Okay, so the composite figure, what are the names of both of these figures in this shape? We've got this kind of box with this thing sitting on top of it. This box right here is obviously a prism, and this is a cylinder sitting on top of it. So we have a cylinder and a prism are our two shapes that we're dealing with. So this left side over here, it's separated by this line, we're going to dedicate to finding the cylinder's volume. And this right side over here, we're going to dedicate to finding the prism's volume. Okay, formula for the first figure, volume of a cylinder. You look at your formula chart, is just big B times H. And volume of a prism is also big B times H. Okay, let's focus on the cylinder. The area of our base, or our big B, our base of our cylinder is obviously a circle. And to find area of a circle, that's pi r squared. So we have pi times our radius of our circle, which is 4 squared. And 4 squared is 16. So the area of our base is 16 pi. And then to find the volume, we would just do big B, which we just found out was 16 pi, times the height. The height of our prism, as you can see right here, is also 4. So 16 times 4 is 64 pi, and we want to leave it in terms of pi, so we do not put the pi in our calculator. Okay, so we've done our cylinder. Now let's focus on our prism. We did write that the volume of our volume formula for a prism is big B times H. But when you have a rectangular prism, you can also use length times width times height. Because the length and the width make up the base, which would be one of our rectangles. It doesn't really matter which one, so I'm going to highlight this guy. So the height, or the length, I guess, of this would be 14, and the width of it would be 12. So the area of our base would just be 14 times 12, which would be 168. So length times width, so 12 times 14, which is 168, and then times the height of our prism, which is 6. So we have 12 times 14 times 6 is 1008. So in order to find the volume of both figures, we have to add them together. But notice that the cylinder has a pi in it and the prism does not have a pi in it. So when we add them together, we actually cannot combine them because they both do not have pi's. So our volume for both of the figures combined is 64 pi plus 1008 feet cubed. Anytime we're talking about volume, we cube our units. Okay, let's go ahead and go to the back of our notes. Okay, we're looking at example number 4. Again, we are finding the volume of the composite figure. Leave your answer in terms of pi. What are the names of both of the figures here? Well, the top figure is a cone, and the bottom figure is a cylinder. So just like the previous problem, we're going to focus on this left side as our cone, and the right side is going to be the volume of our cylinder. So the first thing we need to do is figure out what is the formula for finding the volume of a cone. Well, our formula chart says that our volume of a cone is 1/3 big BH. Okay, so the first thing we need to do is find the big B for the cone. Well, the shape of our base here is obviously a circle. So to find area of a circle, we would use pi r squared. Okay, well notice that this is pointing to the diameter of our circle, which is 4. So that means our radius of our circle would be half of that, which is just 2. So we have pi times 2 squared. Well, 2 squared is 4, so the area of our circle is 4 pi. Okay, so now we can go ahead and calculate the volume of this figure, which is a cone. So we have 1/3 times, I'm just following my formula, 1/3 times the area of the base, which we just found out was 4 pi, times the height of our cone. Okay, well, I don't see anything going from this tip, the point, all the way down to our center. I don't see that. But I do see this over here. The height of the entire composite figure, including the cone and the cylinder put together, is 5. And we also see over here that the height of the cylinder is 2. So that means that our height of our cone has to be 3, because 3 plus 2 would be 5. So we're going to multiply that times a height of 3. So in order to find our volume, we need to multiply all three of these together, not including the pi. So 1/3 times 4 times 3 is 4, because the 1/3 and the 3 actually cancel out. So the volume of our cone is 4 pi, and we're dealing with inches cubed here. Okay, so before we can find the volume of both, we have to go ahead and find the volume of the cylinder next. So let's shift our mind to the volume of a cylinder formula, which is big B times H. Again, the shape of our cylinder is the same. The shape of the base of our cylinder is the same as the shape of our base for the cone. It's the circle. And we've already found the area of the circle from the cone, which is 4 pi. So we already have our answer for the area of the base, which is 4 pi. Now we're just going to follow our formula. Area of our base, 4 pi, times the height of our cylinder, in this case is 2, which is right here. And 4 times 2 is 8 pi. So the volume of both the figures, when we would add them together, because we want both the cone and the cylinder together, 8 pi plus 4 pi is obviously 12 pi. Inches cubed is the volume of both figures. Okay, our last two examples, example 5 and example 6, we are also going to save for class. So I'll see you guys tomorrow.